All right, guys, we're going to do a little more law of sines and cosines and talk about the area formulas today. But first, I'm going over questions on the homework check. Oh, this is not the right page, is it? Okay. Can you read me one of the questions? I think it's like, anybody have it? The cotangent of x equals 2 cosecant or something, I think. So what page is this? Number 37-ish. Okay, I think this one says cotangent of x equals 2 cosecant of x. Does anybody have a book? I could look that up quick. All right, and in the directions it says between negative pi over 2 and pi. So what you are supposed to do is go to your calculator. This is secant back here. Thank you. What you're supposed to do is just type it in your calculator and find all the intersection points between in this window. Yeah, that I just scribbled out. That window right there. All right, so if I go to the calculator, first of all, I want my window to be negative pi to pi. So I just literally typed negative pi, enter, pi, and then I did negative 5 to 5 for my y window. How do I type in cotangent, guys? So I went to y1 and typed 1 divided by tangent. And then secant is 1 divided by cosine, and this says 2 times. You could actually do 2 divided by cosine, but I did 2 times 1 divided by cosine, so people weren't confused. And then if you graph it, just wants the intersection points, and there's just 2 of them for that one. Okay? Does that help? Now you know what you need to do for those. You can turn that in tomorrow. It's fine. Anybody else have a question? Anything on worksheet 22? Worksheet 22, we had number 11. You had a question? Okay. Oh, this is icky. This is a tangent graph, which makes this a little more interesting. All right, what is this -4 doing to the tangent graph? Flipping it, and it's stretching it, but is it the amplitude? Tangent has no amplitude, remember? Because tangent goes up and down forever. Are we good? So we need one of these that has none. So we're down to these 2 choices. What is the period of a tangent graph? Pi divided by 1/2. Yeah, you could have looked at the shift. So the period would be 2 pi, and then this is to the left 3 pi over 4. So A is looking good. Process of elimination, yes. Anything else on worksheet 22? No, that's not for us. You're good. Did you want to go over any of these? We good? Which one? The domain and range of arcsine. We wrote it on our little unit circle. If we think about it, this is the sine graph. Looks like this, right? So arcsine is restricted to this, which normally we would have -1 to 1 and negative pi over 2 to pi over 2. But it flips when you do, because that was the regular sine graph. So the inverse sine, this instead of being left to right would be bottom to top. So they have degrees for some reason. So -90 to 90 would be the bottom to top, which is the range. And the domain would be -1 to 1. which is D. Anything else? Anybody has a question on anything about the homework check? You can turn it in tomorrow and it won't be late. But we are today going to talk about worksheet 24. Does that sound right? Okay. So worksheet 24, side A, talks about some review from Friday. This is a law of sines or cosines question. By the way, guys, this is more what the quiz looks like. Remember last week the notes were all like solve this whole triangle, solve this. This is what the quiz looks like, okay? I will say find RT. Because if you mess something up, then you're messed up for the whole rest of the problem. So I will ask for a specific part of the triangle. So find RT. How can I set up to find RT? Do I need sines or cosines? Law of sines. And I don't even need to find angle R, do I? These are right across from each other. So it would say what? Sine of over 41 equals. Excellent. Okay, type. Make sure you're in which mode, guys? It said 33 degrees and 29 degrees, right? I got 46. Yeah, I guess 0.1. And it's a length. It doesn't need a degree. All right, number 2 is a bit more of a struggle. How do we find angle B up here? We need law of cosines. And how's that going to be set up? There we go. Good job. 10 squared cosine of B. All right. So most of you good for setting it up. Then how are we going to type it in? This is where we tend to go wrong. Yes, good job, Riley. I would suggest you subtract those both over to the other side. So does that come out 26 or something? And if you multiply these together, you get negative 70. So then what do we need to do? So we have 26 over negative 70, and that's the cosine. So we need to undo that. Second cosine of 26 divided by negative 70. The fact that it comes out negative after we divide means that angle B should be what kind of an angle? Yes, obtuse. If we'd ended up with a negative over negative or a positive value, it would have been an acute angle. Does that make sense for this picture that would be an obtuse angle? Now, they don't always draw them to scale, but it should be the biggest angle, right? So, whoops. 111.8, not 118. Just kidding. All right, we good on those two? Everybody typing that, getting that? Anybody having trouble? Law of cosines backwards can be tricky. All right, what about this one? Cosines again, we're trying to find this side, so we can just type this one in all at once. All we have to do is remember to square root at the end. Somebody else get like 1641. $40.5, anybody? Okay. Anybody not getting that? Need some help? Right, the next problem is an application problem. Help me remember, we did not do a law of sines question that might have two answers, so remind me and I'll make one up in a couple minutes, okay? Because I think that's something we need to review one more time, yes? Okay, ones that have two answers. All right, this is a really silly made-up question. It says they want us to not have a right triangle, so they said this lamppost is leaning over 2 degrees. So what is this angle in here now? 92 degrees, okay? Now we don't need this little dotted line anymore. They want us to know the length of the light post, or how tall it was when it was standing upright. So we're going to find this side. Yes? Sure. Thanks. All right. We need to treat this as one giant triangle now. And before we can set up law of sines, we need to know what? Let me uncomplicate the picture a little bit here. Whoa, yeah. 45 degrees, 25 feet, X, and 92 degrees. Clearly. Okay. Yeah, we need this angle so that we can set it up across from the 25. 180 minus 45 and 92 leaves 43. Okay, so now we can set up the sine of 43 is across from 25 feet in the same way the sine of what? 45 is across from X. So the angle is just a little bigger, so it should be just a little bigger than 25, I think. Someone else getting that? Label? Everybody okay? You good, Morgan, or is it not coming out? It's not coming out? Do you have 43 here? Yeah, but you got to close some parentheses. Did you remember to close parentheses? You good? Yep. That I'll do that sometimes, and then I don't get the. Everybody good? Because it brings up that parenthesis, so then you have to close it in the right spot. All right, guys. I'm gonna sound like a goofball to some real math teacher who listens to this. I'm just a fake math teacher. I'm not sure how you pronounce this because I've always pronounced it Heron's formula, and at math contest this weekend, somebody called it Hero's formula. I don't know. Do you remember it? Now, see, I thought if there's something, I don't know. Our book, anyway, the formula is to find the area given the three sides, okay? So when you know all three sides of a triangle, you need what's called the semi-perimeter, which is halfway around. So what you're going to do is add up all three sides, A plus B plus C, and then you're going to cut it in half, okay? They write it 1/2 A plus B plus C. That's the semi-perimeter. And then you take that number and you use it 4 times. You take the semi-perimeter times the semi-perimeter minus side A, times the semi-perimeter minus side B, times the semi-perimeter minus side C, and last but not least, you square that disaster, okay? Now, I'm going to show you how to do this on your calculator so that you can store part of it in your calculator to save a little bit of time and effort. Let's try, okay, I'm going to show you on your calculator, but then we're going to use a different number than this one, okay? To store a number on your calculator, do you find next to the on key, right above the on key is this STO? You can store a number into any variable on the calculator, but the easiest one is just to use X. And it won't matter later that you stored something in X, okay? It's not like you have to unstore it or it's going to screw up some calculation. It's not the way it works. So I'm going to actually go to this problem, I think. You guys have this number 5? Okay, let's find the semi-perimeter. So can you do 36 plus 20 plus 22? And that is 78, is that right? And then you cut that in half, so you get S is 39. So now let's store 39 in X. So what you do is, let me get this off here. You go to type 39, and then this STO key down here by on, and then X, your X key next to alpha, and hit enter, and it just says 39. Now, if you want to check, just go back and type X, enter, and it says, yep, there's a 39 in there, okay? So now what I can do is I can type square root of, and then I can put all this in. X times parenthesis X minus 22 times parenthesis X minus 20 times parenthesis X minus 36. Now, it doesn't seem like it saved that much time and effort, but sometimes that S value is like 25.835. Nobody wants to type that 4 times, right? Did someone else get 194.4? Okay, so the area here, after we did all that craziness, I'll write it down real fast. Except I'm running out of room. 39 minus 36. Yep, doesn't really fit. Was how much again? I already forgot. Good job, label and all. Okay, so that's here in formula. And when do you use it? For area, and you know all 3 sides. Okay, area, and you know all 3 sides. Why don't you pick one of these and try it? Okay, you don't need to do both. Pick one of these 2 and try it. Okay, I didn't really store it all. I kind of cheated, but is anybody getting that or not? 33.7 square feet. I just did all the subtracting in my head, so probably wrong. 47 on the other one. All right, here's formula. By the way, let's take out the blue sheet because you're going to be happy to see. Underneath your unit circle, underneath the unit circle, what does it say? It says law of sines, law of cosines, area of a triangle, Heron's formula, and there's one more thing down there. There's one more area formula that looks like this, 1/2 AB sine C. Yes? Okay. This formula, I only put, I think, this one on your reference sheet. Sorry. Is for when you know a side, another side, and the angle in between. The area of this triangle would just be 1/2 10 times 14 times the sine of 36 degrees. I like this area formula, okay? You actually could use this area formula to do these questions. How could I do that? If I know I had 8, 12, and 13, how could I use this new one that says 1/2 times the side times the side times the sine of an angle? Yeah. I could do law of cosines to find one of the angles, yes? And then if I had found, say, this angle, then I would put 8, 12, and the sine of whatever that angle was. The problem is using law of cosines backwards takes a lot of time to begin with. So, all right. I always have to sketch the picture because I want to make sure I have things in the right place. Because, for example, number 9 is going to be a little bit tricky. So can somebody tell me what I'm going to type here? And you could just do times. You don't need parentheses. And for 1/2, you can use 0.5. $64.3. Okay, we could have used some right triangle trig to find the height and used 1/2 base times height. But this is pretty fast, right? So if we have this information, this is the easy way to do it. Any questions? Anybody not getting that? All right, M and P, this one is a little bit trickier. It says there's a 110-degree angle, which my picture is clearly not to scale. And side N over here is 14. Can I use either one of those two that we just learned? Not right off the bat, but I can use law of sines to find some more information, right? What do I really want here? Another side, maybe side M over here. And then we'd be able to do our 1/2 AB sine C. So we're going to need to find angle M. That's not too tricky. 180 minus 135, is that right? 45 degrees at M. Now we can find side M by sine of 45 is across from M, in the same way sine of 25 is across from 14. That's really messy. Don't forget to close your parentheses, but yes, I did get 23.4. I might carry a couple extra places on that one because I'm going to use it. All right, now what am I going to do to find the area? 1/2, which two sides do I want to use? Well, the only two I have, right? That was a pretty brilliant question. But which angle? Yes, because that's the one in between. That's again where I always draw the picture because then I don't inadvertently use the wrong thing, okay? If I have the picture all set up, it's just 1/2 times the 2 and the angle in between. And it's always going to depend how you rounded and whether you type the whole thing in, because sometimes you just leave the number on your calculator, all that good stuff. I got about 154, maybe 0.1. And that was square feet, right? Honestly, the thing that students get wrong the most on these is they don't read the directions. When it says find the area, you have to use one of those two formulas, right? It's not that complicated. They're on the blue sheet and you'll get to use the blue sheet. Generally what people do is they like start finding all the extra sides and angles like it said to solve or something, okay? As long as you remember that the formulas are on the blue sheet and how to use them, and you read the directions where it says find area, they're not hard. Right, this is a quick application question. This word is underlined and italicized for a reason. Okay? This is, they paint on barnwood these quilts patterns. Sounds really pretty. Imagine a whole barn covered with paintings of quilted patterns. That'd be very cool. But they want us to find the area of the yellow. Do we have any information about the yellow? It's symmetrical, so it's exactly the same size and shape as which piece? The blue. Everybody okay? Symmetrical means like we could turn it and flip it and whatever, and it would match up with the blue. So basically, if we can find the area of the blue, we'll have the area of the yellow. Does that sound like a plan that I won't have to redraw it? Okay, what are we going to have to do, though, to find this area? We need another side, right? Okay. 35 degrees maybe down here. Does that work? So then we need to maybe find this side over here. So the sine of 35 is across from x as the sine of 45 is across from 6.5. Anybody getting 5.27-ish? No? Did I type something wrong? Okay. So now the area we want to find is of a triangle that has a 5.27 here, a 6.5 here, and the angle in between was 100. So our area would be 1/2 5.27 or 5.3, whatever you want to do. 6.5 times the sine of 100. Anybody getting 16.9-ish? Square feet. Okay. What do we need to do if we need to give that yellow area 3 coats? Okay. So we're going to give each of those 3 coats. So we need to buy 3 times that much paint. I got 50.6, but if you round it, is it 50.7? Okay. I didn't round until the very end, so somewhere in there. Now, that's how much combined area after the 3 coats that we're doing. How much paint do we need to buy? If each square foot, 1 square foot, requires 3.5 ounces of paint, yes. We think of it like a proportion, we're multiplying, times 3.5, no. 177.2, but I like didn't round and then I rounded and then I was somewhere in there. You guys got 178. What did you get? Yeah, it depends where you rounded. Yeah, I got 177.2. You might have got all the way up to 178.4 or 0.8. 0.08, so 0.1. Nobody got anything bigger or smaller than those somewhere in there? Okay. And that's ounces. The question doesn't specify. It would probably make more sense if we figured out, how many quarts of paint that was and rounded to the nearest quart, because you can't buy it by the, but we're just going to go with we're done. Does that sound like a plan? All right. This is actually a question that this idea shows up a whole bunch of times on worksheet 25 and 26, okay? The trick to this question is that if this is a 63 and this is a 72, does this line falling down here cut this in half, 250 and 250? No. That's what students want to assume, okay? Can we find this angle up here? Is this angle up here cut in half equally? No. Because these are 90s, so this half would be like 27 and this half would be like 18 or something. They're not the same, right? What we have to do is treat the whole thing as one giant triangle for a minute. Yes. And if this is 63 and this is 72, Basma subtracted and got 45 up here, you said? Okay. And this is 500. Well, is that going to help us find this height down the middle? I want that. I have to find another piece of information before I can find that. These are two-step questions, okay? You can either find this side or this side. Which one do you want to find, guys? A? Okay, we're going to find A. So we're going to say the sine of 72 is across from A, in the same way the sine of 45 is across from 500. Type, type, type. Okay, so now we know this. Now we want the height. Well, if it's a height, what's it making at the bottom down here? 90 degrees. So we have 672.5, 63 degrees, a 90, and we want the height. You can still use law of sines. I know a whole bunch of you are going to use law of sines still, okay? You can also just use SOHCAHTOA stuff because it's a right triangle though, right? So the sine of 63 degrees equals the opposite side, which happens to be an h, over the hypotenuse, which is actually the 672.5. And you can just do right triangle trig. But it's the same answer I promised if you do law of sines. Yeah, 599 point something. I kind of remember that number. 599.2. So the blimp is almost 600 feet overhead. That idea where you have to find some distance and then use that to find the height or something like that is used a lot on those application worksheets, which are 25 and 26. Any questions on those? We have one more. And then don't forget, I want to do one where we might have two possible solutions. Actually, this one will help us review that a little bit, I think. But okay, the McBigs plan to fence a triangular parcel of land. One side is 75 feet in length and forms a 38-degree angle with another side, and that side we haven't measured. But the other side that we have remaining is 95 feet in length. Approximate to the nearest tenth the length of fence needed to enclose this parcel. So we need to find the perimeter eventually, yes? But what are we going to have to do first? We are going to have to do law of sines. We need to find this side, but we're in trouble. We can't find that directly, right? We're going to have to find this angle first over here. I'll call it angle F for first. How's that? So the sine of that first angle is across from 75. in the same way the sine of 38 is across from 95. As soon as you set up and know you're going to have to do second sine, you're supposed to have a little alarm go off in your head that says I could have two solutions, right? So if I type this, I get a decimal. .4860, and then I do second sine of that, and I get angle F could be, anybody get 29.1? And how do you find the other possibility? 180 minus 29.1 would be what? 150.9? Should just be 180 minus 29.1. Okay, now there's my two possible angles for F, but if I know I already have a 38, can I have a 150? No, this angle cannot be 150.9 because there's already a 38 in here. So this angle has to be 29.1. Now can we find this guy up here? 180 minus 38 and 29.1 is 112.9. Now we can finally find side X. Anybody get X? Okay. Is that the answer? No. They still want how much fence we need all the way around. So 75, 95, and 142.1. 312.1. Now, if you're going to buy fence, might come in yards, might come in feet, you'd probably buy some extra. There's a question very similar to this on worksheet 25, and that question says they want to buy 5% extra for waste, you know, what might be wasted. How would you say I want to add 5% onto that? Yeah, you could multiply by 0.05 and then add that back on, or you could just multiply by 1.05 because it would be 100% plus 5%, right? All right. I promised this is the assignment then, and we will have time to work tomorrow, okay? On worksheet 25 and 26 and ask questions. Some of you worked on 298 already, maybe. A couple of you. Morgan did. All right. Real quick example. I'm going to try to make one up that works. If this is a side of 10 and this is a 32-degree angle, and I tell you there's another side over here that's 8. Okay, let's see if this makes two triangles or not. What would you set up to find first? That angle up there? Let me call this ABC so we get a little less confused here. So you'd have the sine of B is across from 10 in the same way the sine of 32 is across from 8. Can you guys help me real quick and see if this has two solutions? I got 41.4. Or 138.5. How do I know if I get to throw either of those away? Because there's a 32, right? Is it possible to have a 138 and a 32? It's only 170, right? So it is possible. So if this was a solve the triangle question, you now have to do everything twice. It's not as complicated as it sounds. Angle A is 32 no matter what, right? Side A is 8 no matter what. Angle B, or side B, is 10 no matter what. But angle B could be either 41.1 or 138.5. Now, does that change C? Absolutely. You have two different values of C. 180 minus 41.1 and 32 leaves 106.9. Or 180 minus 32 and 138.5 leaves 9.5. Now, is that going to make two different values of side C? Yeah, because this side C is going to be a whole bunch longer than this side C, right? Okay. But did that review that concept for you of when there's two possible solutions and what you have to do to solve the triangle?